Hello. Now we are going to take the last exercise of homework 4. So that's exercise 3. And here we have to consider the random variable x with probability density function given by density function f of x equal 1 divided on b minus a when x is greater or equal a and less or x less or equal b and 0 otherwise. We say that x has the uniform distribution on a comma b. And we are asked to show that the expectation of x is equal a plus b divided on 2. Okay, let's do it. The expectation of a continuous random variable, we know that it's given by the integral. And here from a to b, x times 1 divided on b minus a dx. And this we just integrate. 1 divided on b minus a is a constant. X integrated is 1/2 times x in the power of 2 ba, upper and lower limit. And then we put in b and a, so we get b in the power of 2 over 2 times b minus a. Then b is put in for x. And minus the lower limit, a in x will be a in the power of 2 divided on 2b minus a. And this we can combine like this, b in the power of 2 minus a in the power of 2 divided on 2b minus a. And this is b minus a, b plus a divided on 2b minus a. So then I take this one against this one, and we get the result we wanted, b plus a divided on 2, which is the expectation of the random variable x, or a plus b then. And then we are going to show that the variance of x is equal b minus a in the power of 2 divided on 12. We know that the variance of x is given by the expectation of x in the power of 2 minus the expectation of x in the power of 2. And we already know this last term because the expectation of x is b plus a So this one is b plus a divided on 2 in the power of 2, but we have to find this one. We don't know that one. So then we have to calculate it. So expectation of x in one is like the integral from a to b, x in the power of 2 times 1 divided on b minus a dx, which is equal 1/3, or the constant 1 divided on b minus a just stands there, times 1/3 x in the power of 3. BA. And then we fill in, and we get b in the power of 3 divided on 3 times b minus a, minus the lower limit, a in the power of 3 divided on 3 times b minus a. Which is the same as b in the power of 3 minus a in the power of 3 divided on 3 b minus a. And then let's go back to the variance. Let's go back to the variance of x, which was equal the expectation of x in the power of 2 minus the expectation of x in the power of 2, like this. And then this first one, we know that this is b in third minus a in third divided on divided on 3 times b minus a. And then we remember that the expectation of x is b plus a divided on 2. b plus a divided on 2. And that shall be in power of 2. And then we have to do some calculation and manipulation here. So we get b in third minus a in third divided on 3b minus a minus b plus a in the power of 2 divided on 2 in the power of 2, which gives b in third minus a in third. And we have to, okay, let's do it slowly. We get we have to time with okay, let's 3b minus a minus b plus a in the power of 2 divided on 4, and then combine these two. We have to multiply here with 4, so we get 4 times b in third minus a in third divided on 4 times 3b minus a minus, and here we have to multiply with 3b minus a, b plus a in the power of 2 divided on 3 times 4b minus a, like this. And then we get 4b in the power of 3 minus let me just write this as 2 parentheses instead. So then we get minus 4a in third divided on 12b minus a minus, and I let this 3 just stand there, and I get, we can do it like this, minus 3, and then I take these two together. That is the third the conjugate sentence. So this is b in the power of 2 minus a in the power of 2 times b plus a. And then this is 4b in third minus 4a in third minus 3b in third plus minus a plus a b in the power of 2 minus a in the power of 2 b minus a in the power of 3 divided on 12 b minus a, and then we just multiply this last 3 inside the parenthesis, and we get 4b in third minus 4a in third minus 3b in third minus 3ab in the power of 2 plus 3a in the power of 2b minus plus 3a in third divided on 12b minus a. And then we can take this, and we get 1. So we have b in third, and we then have minus 3a in the power of 2b plus 3a in the power of 2b, and I can put this with this, and we have minus a in the power of 3 divided on 12b minus a. If you know your binomial coefficients, that was not very good English, as much of it is. It's not very much good English here. That's what I'm saying. But this we can write out like b minus a in the power of 3 divided on 12b minus a. I don't know if you see this, but hint, look up Pascal's triangle. The easiest way to write it is like this. And this continues infinity. And then I can cancel this out, and we get my b minus a in the power of 2 divided on 12. And that is exactly what we was asked to show. You can see it there. Good. Then we can go to B. Find an expression for the cumulative distribution function. So f of x, we know how we find it. It's to integrate from the lower limit a to how long we want to go, x. And we are integrating the density function f of x dx. And putting f of x, we know what is. That is 1 divided on b minus a dx and this is just equal 1 divided b minus a x, xa, and we get, putting x in for x, that's not perfect notation, but now we have done it, x divided on b minus a minus a for x, a divided on b minus a, and we get x minus a divided on b minus a. That is the CDF, or cumulative distribution function. So in C, use the expression from B to compute the probability of the event x greater than a plus b divided on 2. So, okay, this is, the CDF is actually just the same as the probability of x less than or equal x. So now we are asked to find the probability of x greater or equal a plus b divided on 2. That's the same as finding 1 minus the probability of x less or equal a plus b divided on 2. And this is just the same as 1 minus f of a plus b divided on 2, which is 1 minus, and then we put in a plus b divided on 2 for x here, in for x in f of x. This is f of x, remember? This is f of x. So then we get x is a plus b divided on 2 plus b, and all this divided on 2. And then I just expand by multiplying 2 here and here, in numerator and denominator. And we get 1 minus a plus b here is something I don't, oh yeah, sorry. Here it's minus a, this one. X is a plus b over 2, so a plus b over 2 is the x, and a is a. So I don't know why the b stood there. Times 2, and we get minus 2a divided on 4. Sorry, but here it just happened some problems. So I haven't filled in right. So let's do it again. 1 minus x is a plus b divided on 2 minus a divided on b minus a. And then we just times 2 here and here, expand like this, and we get 1 minus a plus b minus 2a over 2b minus 2a, which is equal, combining this, so we get 2b minus 2a over 2b minus 2a minus a plus b minus 2a over 2b minus 2a, and then 2b minus 2a minus A minus B plus 2A divided on 2B minus 2A, and we get, calculating here, 2B minus B is B, minus 2A plus 2A cancels out, and we have minus A, and under we have 2B minus 2A, and we get B minus A divided on 2 factorized outside a parenthesis, B minus A, this against this, and the result is 1/2. So there is all correct. So this is the probability of x greater or equal A plus B divided on 2. And then lastly, we are going to simulate this probability in Python. But now we put values on A and B, but and then we draw numbers from this uniform distribution. We draw n numbers from the uniform distribution, and we check if x is greater or equal A plus B divided on 2. And if it is, it will be a 1, and otherwise it will be 0. And then we take the mean of all these 1s and 0s, which is the proportion of how many x's which is bigger or equal A plus B divided on 2. And it should be, if you look to the theoretical result, it should be very close to 1/2. So let's run it. And we got pretty close, 0.5. So that's it. Good run.